Hello students, today I'm going to explain the solution of your online evaluation. First, let's start reading the given. The exercise is about tension and elongation of a spring. Consider an elastic spring and a solid mass of mass m given that G is 10 Newton per kilograms. In the first part of this exercise, we are going to study the characteristic of a spring. The adjacent figure shows within the elastic limit of the spring. This means that within the maximum elongation of the spring beyond which the spring loses its elasticity. The variations of the tension T as a function of the elongation delta L of the spring is given. Referring to the graph, complete the table below. So here when you are given 2 Newton, you have to go back to the graph, check the y-axis on which the magnitude of the tension is put, and refer to Newton, take perpendicular and see it meets the graph at this point, then go vertically downwards perpendicularly to the x-axis. This corresponds to a value of delta L equals 1. In the second column, we have delta L is 2 centimeters. So now we have to do the opposite work. Go to 2 centimeter vertically perpendicular until it meets the graph. Then at this point, go perpendicularly horizontally, perpendicular to the y-axis. It is 40 Newton. So for 2 centimeter, for elongation of 2 centimeter, the tension is 40 Newton, and so on. So here is the solution for 2 Newton, 1 centimeter, for 263. Then they ask us in part 2, they said that K represents a characteristic physical quantity of the spring. Give the name of this characteristic, give its value in SI unit, and give the name of the law that relates T, K, and delta. So, as long as the objective of this lesson is to characterize the spring, and we know according to your required knowledge that the characteristic of a spring is the stiffness. So K represents what? The stiffness. In part B, they asked you to find it in its SI unit. Previously in this table, we calculated it in Newton per centimeter. However, the SI unit of K is Newton per meter. And in order to convert from Newton per centimeter to Newton per meter, we have to multiply by 100. So the value becomes 200 Newton per meter. This is the SI unit. And finally, the law that relates the three parameters is Hooke's law. Part B. For part B, we are going to study the equilibrium condition of the solid S connected to this spring. We suspend the solid S from the free end of the spring S, which is at rest. Give the name of the two forces acting on S. Any object on Earth is under the effect of the gravitational force on one hand, and since this solid S is suspended from an elastic body, which is the spring, then it is also subjected to another force, which is the tension force. When we give the name, we have to give also the symbol of this vector, or of this force vector, because when we use the symbol later on in the upcoming parts, we have to define the symbols that we use. So that's why in the part where they ask us to name the force, we have to give it also its symbol. Write down the vector relation between these two forces. When they say vector relation, so we have to stop on the vector relation and do not continue writing the magnitude relation. This means that we write at equilibrium the sum of forces is zero vector. So T vector plus W vector equals zero vector. Then T vector, bringing W to the other side, it becomes minus W vector to show that they are opposite vectors having opposite directions. And we have to stop here. If you continue to write T alone equal W, and you give the magnitude relation, then your answer is considered to be wrong. Deduce the relation between T and M. Now they are asking you for the relation between the magnitude of these two forces. So we continue to say that as long as T equal minus W, T vector is equal to minus W vector, then T equal W. This is the relation. And now W is equal to M times G. So in this way we found the relation between T and M.